Hello class, so today we're going to go ahead and do this next example, so let's go ahead and see what's going on. So I got an integral that is going to start at 2 and end at 6 for my limits of integration, and I'm going to see that this function is some x to the third with respects to x. So let's go ahead and begin on what we have here. If we go ahead and remember from our notes, we can go ahead and see that the integral, all the integral is a limit of a summation of the area of a rectangle. So the height is given to us by this function times the width of each little rectangle when our rectangles go towards infinity. Okay, so let's go ahead and begin on what this means. Well, let's go ahead and notice. Well, if we have the following, we can see that we can find the delta x as the function given to us by our b minus a divided by n, which we have already been doing for our left endpoints and our right endpoints, and even our trapezoidal and our midpoint. And it tells me my b is my upper limit of integration, which in this case is 6, minus my a, which is my lower limit of integration, which in this case is 2, divided by n. So I got 4 over n as my limits, as my delta x. Let's go ahead and save this information because we're going to need it later. So this is my delta x. And we'll replace this part right here. My next part says that I'm going to go ahead and find my x's. So my new x's are determined by a plus my change in x in the initial, meaning where I is going to change all the way to n. So that's going to go ahead and give me my first value, which is a, in this case is 2, so it's going to be 2 plus my change in x, which I already know that right here, I solved for it already. It is going to be plus 4 over n times I. So I'm going to go ahead and make this a little prettier, so it's going to be xi is going to be 2 plus 4i over n. I'm going to go ahead and save this information right here because I'm going to need it later. And just a friendly reminder, this is my new x's. Okay, now can we identify the function that we are doing here? So if we can go ahead and see, there's going to be some x to the third power. So our function should be f of x is equal to x cubed. Well, not only x cubed, we need to go ahead and notice that inside the cube we have a plus 2. So be very careful. So it's going to be f of x is going to be parentheses x plus 2 cubed. So very different. Our x's are still the same. Our x's are still going to be the same. I'm sorry, my new x's are still going to be the same, but remember you have to add a plus 2 that it's going to have. Well, let's go ahead and do our answer. Not that bad. It's going to be the following. So it's going to be the limit as my rectangles approach infinity. We find the area of the rectangle starting with the first rectangle, initial equals 1, all the way to n, for the rectangles, which is the height to the third plus 2 of my new value, my new x's, which I found over here. So those are going to be, I'm going to run out of space, 2 plus 4i over n. Oh, I made it fit. Yay. So it's going to be the following times the delta x, which we found already, and that's going to be my 4 over n. So remember guys, we already know our change of x, we just solved for it. We know our new x's, and the function that we found was this right here. Now, if we look at this part right here, we can see that there's some stuff that we can go ahead and combine. This 2 and this 2 can go ahead and combine like terms. So our answer should be 2 plus 2, that gives me 4, plus 4i over n to the third times my delta x is here. Let's go ahead and make this a little prettier and put our limits as n goes to infinities as we sum up the areas starting with my first rectangle and so on. So my answer is this one right here. This part right here. Oops. This part right here is my solution for my integral. So this gives me an exact area under the curve, just as if I was to do this right here, like we learned before. Thank you, and